In this next example, we're going to see some problems still with rational exponents, but we're going to be using some of our exponent rules. All right, so just as a refresher, when we multiply like bases, we want to add the exponents. When we divide like bases, we want to subtract the exponents. And when we raise a power to another power, we multiply the exponents. So let's get started with example A. So in this example, if it looks weird to you, it might be because sometimes you might see a multiplication dot in between these. But these are still next to each other, which means that they are being multiplied. So because they are the same base, we can go ahead and add those exponents. So I'm going to rewrite this as x to the, and in the exponent, I'm going to add 1/2 plus 1/3. Well, we know that when we add when we add fractions, we need common denominators. So our common denominator here would be 6. So 1/2 with a denominator of 6 will become 3/6, and 1/3 with a denominator of 6 will become 2/6. All right, so we can do that subtraction. 3/6 minus 2/6 is 1/6. And what we can do now is we can rewrite that as an exponent. We could leave it. Oh, I'm sorry. I made a mistake. We shouldn't be subtracting here. We should be adding, because we're multiplying like bases, not dividing them. So 3/6 plus 2/6 is actually 5/6. Sorry about that. So we could leave our answer this way if we wanted to. We could also turn that into a radical. So if we did that, we would have the 6th root of x to the 5th. So either one of these is an acceptable answer. It all depends on how you're being asked to give the answer. All right. In the next example, we do see division. So now we are going to subtract. So I made that mistake here, but this is the place where we want to subtract. So we do have like bases. So we're going to do 7, and I'm going to do the numerator's exponent minus the denominator's exponent. So that's going to be 1/3 minus 4/3, all in the exponent. So 1/3 minus 4/3, that gives me negative 3/3. And negative 3/3 simplifies to -1. All right, so now we know that we shouldn't leave answers with negative exponents. So to get rid of that negative exponent, we just have to reciprocate. So that's going to be 1/7 to the first power, positive 1, which is just 7. So 1/7 is our final answer. In example C, notice that we do have a negative exponent here, but before I start reciprocating right away, I'm going to take a look at the problem as a whole. Because these are multiplying, or these bases are multiplying, if you plan ahead, you can see that if you add these exponents, you completely get rid of any negative exponent, because we're going to end up with a positive exponent. So I'm not going to reciprocate. All right, in this case, it's going to be easiest to just go ahead and work with that negative. So I'm going to rewrite this as y to the negative 4/7 plus 6/7, and that's going to give me a positive 2/7 in the numerator. And you could leave that as your final answer, or if you wanted to rewrite this as a radical, this would be the 7th root of y squared. So once again, it all depends on how you're being asked to give the answer, whether it's with a rational exponent or in radical form. All right, this next example is a bit more complex. So we can see that now we have powers being raised to powers. So we're going to be multiplying exponents. In the numerator, we have 3 bases. 1, 2, 3. You have to remember that 2 has its own exponent, and in this case, it's 1. So when I multiply this 5 into every exponent, 2 is not attached to x to the 2/5 power. 2 has its own exponent. So this is going to become 2 to the 5th. Right, I'm just multiplying it into every exponent. 2/5 times 5, well, 2/5 times 5/1 is going to give me 10/5. And 10/5 is just 2, so that's x squared. And then for y, negative 1/3 times 5, it's going to be negative 5/3. Alright, and then next, we can see that in the denominator, we don't have to distribute anything, so I'm going to go ahead and leave it as it is. I'm going to simplify this. 2 to the 5th is going to be 2 times itself 5 times, and that equals 32. Alright, I'm going to simplify that. I'm just going to rewrite everything else that I have. Alright, we can see now everything has been simplified. These we can start dividing. So x squared divided by x squared, that cancels out, gives us 0. Then we are left with 32 y to the negative 5/3 all over y. And the exponent of that y in the denominator is 1. So we have like bases right here. We should subtract these exponents. Alright, so I'm going to end up with 32, and I'm going to do y, and in the exponent I'm going to have negative 5/3, and I'm going to subtract 1, but I'm going to subtract 1 with its common denominator, so I need a common denominator of 3. So 1 rewritten with that denominator is 3 over 3, so I have minus 3 over 3. So I'm going to go ahead and simplify that. Negative 5/3 minus 3/3 is y to the negative 8/3. And I can't stop here because I still have a negative exponent in my answer, which we know shouldn't be. So I'm going to go ahead and move this to the denominator. So 32 has a positive exponent. It technically has an exponent of positive 1. So I'm going to leave it in the numerator. But I'm going to move this part to the denominator. Alright, so we could leave our answer that way. If you wanted to rewrite this in radical form, you could write it as 32 over the cube root of y to the 8th. So once again, depending on how you're being asked to give the answer, either one of these is an acceptable answer.